Okay, so the first thing we're going to talk about here in Unit 3 is gravity. And we're going to define what gravity is and some of the difference between something called gravitational mass and inertial mass, as well as define what is gravitational field strength. So the first thing is we've been talking about gravity and Newton's laws, right? We've been talking about what exactly is it. But here we're going to talk about how it is a force of nature that attracts one mass over or to another. So it is one of the four fundamental forces of nature, and you can see over here on the right-hand side of the screen, you've got gravitation, electromagnetism, strong force, and weak force. So gravitation, of the four forces listed, it is actually the easiest because it's the easiest to break away from. The other three are a little bit stronger. Okay, or much, let me say a little bit. They are much stronger than gravity. Okay, so though the effects of gravity are all around us, it is weakest of the, like I just mentioned, it is weakest of the known forces of nature. Okay. So gravity, much like what the electromagnetic force, it's a field force. So what happens is there's a field surrounding a central object. Therefore, it's attracting everything towards that central object. And up until this point, all the forces that we really discussed have been what we call contact forces, right? So forces like tension, friction, okay, and that normal force that we've talked about when we did friction and unit 2. Okay, now what happens is once you get into a gravitational field, you're going to experience the effects of gravity. Okay, so we've talked about the weight equation, right? Fg equals mg, right? So that is what we call, that is the magnitude of the gravitational field strength. So if I think of gravity as a vector, okay, then we just say that it's g is equal to F over m, right? Where this is not now the acceleration due to gravity, it is what we call the gravitational field strength. Okay, which, and you can note here in this picture is, right, gravity is going to pull straight down the earth, and you'll see that these arrows are different sizes because gravity is dependent on, right, how far you are away. And we'll get into that when we talk about Newton's law of universal gravitation, because you'll see in that equation there is a distance or there's a distance factor that comes along with it. So remember, this equation here is the weight, but it is the magnitude of the gravitational field strength, right? So it's what we experience once we get into that gravitational field. Much like once you get into an electric field or a magnetic field, that's what you're experiencing, okay? But one thing to note is that most of the other fundamental forces can be attractive or repulsive. Gravity only attracts, okay? So in the next video, we're going to look again, we're going to revisit our good old friend Isaac Newton and talk about his law of universal gravitation.